What if one of the most advanced industrial materials of 2026 didn't come from a laboratory, but from a banana field you pass without noticing? What if the thick green stems left behind after harvest were no longer waste, but the raw input for global industries? This is not a story about bananas. It's a story about what happens after the harvest. When automation replaces manual labor, AI replaces guesswork, and sustainability becomes profitable. Welcome inside a factory you've never seen before, where pseudostems become products, waste becomes value, and one overlooked crop is quietly reshaping the future of materials. The rise of the high-tech banana stem factory. For decades, banana farming ended at the harvest. The fruit moved to market, and everything else was treated as residue. Today, that ending has been rewritten. In 2026, banana stem processing has fully entered the industrial age. What was once a slow, labor-intensive cottage activity is now driven by automation, AI, and precision engineering. High-tech factories operate alongside banana farms, turning what was once agricultural waste into a continuous industrial input. The moment banana stems arrive at these facilities, the process is seamless. Intelligent intake systems assess moisture, density, and fiber potential in seconds. AI-guided handling equipment adjusts automatically, ensuring consistent processing despite natural variation in the raw material. There is no guesswork, only data-driven control. Extraction lines run at scale, separating fiber from pulp with speed and accuracy unimaginable a decade ago. Integrated monitoring systems regulate drying, treatment, and finishing in real time, reducing energy use while maintaining uniform quality. Every stage is designed for efficiency, repeatability, and minimal waste. What makes today's factories transformative is not just technology, but integration. Agriculture feeds industry directly. Waste becomes feedstock. Byproducts become secondary outputs. Rural supply chains gain value instead of losing it. The high-tech banana stem factory is no longer an experiment. It is a mature, scalable system. It proves that modern manufacturing doesn't always begin with new materials. Sometimes, it begins by finally industrializing what has been growing in plain sight all along. Now, let's move inside and follow the process step by step, from arrival and sorting to extraction, treatment, and final production. Step 1. Intelligent raw material handling. Fresh banana pseudostems vary widely in thickness, moisture, and fiber density. In older systems, this inconsistency caused waste and inefficiency. Modern factories solve this with AI-driven sorting systems. Advanced sensors scan each stem, measuring moisture content, diameter, and fiber potential. Robotic gripping arms, guided by machine learning, adjust pressure and positioning in real time. No two stems are treated exactly the same. This adaptability alone has dramatically reduced material loss and improved output consistency. Step 2. Automated fiber extraction. At the heart of the factory lies the extraction line. Gone are the days of manual scraping. High-speed rotating blades and precision rollers now separate fibers from pulp with remarkable accuracy. The machines peel away layers, isolating long, clean fibers while minimizing breakage. These automated extractors achieve fiber yields of 65 to 70%, compared to roughly 50% in traditional methods. That jump doesn't just increase efficiency, it changes the economics of the entire industry. What was once waste is now a reliable raw material stream. Step 3. Smart processing and real-time control. Once extracted, fibers move into controlled processing zones. This is where IoT-enabled systems take over. Sensors continuously monitor temperature, humidity, drying time, and fiber alignment. If conditions shift, even slightly, the system automatically adjusts airflow, heat, or processing speed. This real-time feedback ensures uniform quality while drastically reducing water and energy consumption. Nothing runs longer than necessary, nothing overheats, nothing dries unevenly. Efficiency here is not just mechanical, it's intelligent. Step 4. Enzymatic treatment for superior quality. One of the biggest breakthroughs in 2026 in banana stem processing is enzyme-assisted separation. Natural enzymes are introduced to break down non-cellulosic components that bind fibers together. This process replaces harsh chemicals and reduces mechanical stress on the fibers. The result? Processing time drops by up to 40%, while fiber softness, strength, and flexibility increase, especially important for textile-grade material. This is where banana fiber evolves from an agricultural byproduct into something refined enough for fashion and advanced manufacturing. Nothing wasted. In these factories, waste simply doesn't exist. The pulp left after fiber extraction is collected and repurposed. Solid remnants are carbonized into smoke-free charcoal briquettes, used as clean burning fuel. Liquid waste streams are treated and redirected into compost systems or animal feed supplements. Even microscopic cellulose particles are captured for advanced applications. Every output has a destination. Every byproduct has value. Eco-friendly bleaching without compromise. For applications requiring lighter or white fibers, high-tech factories now use non-toxic, eco-friendly bleaching systems. Unlike conventional chemical bleaching, these processes preserve fiber integrity while producing silk-like brightness. The fibers remain strong, flexible, and biodegradable, ideal for premium textiles and packaging. It's sustainability without sacrifice. Textiles and fashion. The finest inner fibers, often called banana silk, are transformed into soft, breathable yarns used in both traditional and contemporary fashion. Designers value these fibers for their natural sheen, strength, and sustainability. From heritage garments to modern luxury collections, banana-based fabrics are blended with cotton, linen, and silk to create textiles that feel premium while remaining eco-conscious. What was once agricultural waste now appears on runways, in boutiques, and in wardrobes, designed for a future where sustainability defines status. Sustainable packaging. Banana stem fibers have become a powerful alternative to plastic and wood pulp. High-tech factories produce biodegradable bags, food-grade wrappers, molded packaging, and even banknote paper. Driven by global mandates to reduce single-use plastics, these materials offer strength, hygiene, and compostability, breaking down naturally without sacrificing industrial performance. Advanced composites. Beyond consumer goods, banana fibers are reshaping heavy industry. Automotive and construction sectors now use banana fiber composites for interior panels, insulation boards, and structural components. Lightweight yet strong, these materials reduce carbon footprints while proving that nature, when engineered intelligently, can outperform expectations. The bigger agricultural impact. High-tech banana stem factories don't just change manufacturing, they reshape farming economics. Farmers now earn additional income from stems that were once discarded. Local processing reduces transportation emissions. Rural employment increases, not through manual labor, but through technical, skilled roles. Agriculture becomes circular. Farming becomes smarter. Why this matters in 2026. By 2026, the global push towards sustainability is no longer optional. Plastic bans, deforestation limits, and carbon targets are reshaping industries. Banana stem factories sit perfectly at this intersection, turning renewable waste into scalable solutions. They prove that innovation doesn't always require new resources. Sometimes, it just requires seeing old ones differently. The next time you see a banana plantation, remember, the fruit is only half the story. Inside high-tech factories, discarded stems become textiles, packaging, and advanced materials. Waste turns to value. Sustainability turns profitable. This isn't the future, it's happening now. Thanks for watching. Subscribe for more unseen innovations.